All right, this video is on the law of constant composition. Another description, another name for the law of constant composition is the law of definite proportions. Now, there is a legitimate math component that goes along with this, but we're not really going to focus on it in this video. We are mainly going to focus on this particular definition, which states that the law of constant composition states that in any particular chemical compound, okay, and understand compound, right? We're not talking about molecules. Or elements, but compounds, all samples of that compound will be made up of the same elements in the same proportion or ratio. Okay, so what I mean by that is if I was to take water, which we all know it has a formula of H2O. What this means is that all water, regardless of how much you have or what state it's in, how much pressure is being exerted on it, whatever, it's always going to be 2 hydrogen atoms for every 1 oxygen atom. Okay, or if I was to have table salt, right? Table salt is sodium chloride, right? That compound is composed of 2 elements, right? Sodium and chlorine. In this case, it's in a 1-to-1 ratio, or 1 sodium to 1 chlorine. All right. The hydrogen, or the water, would be 2 hydrogens to 1 oxygen. Now, the type of problems that you're going to come across with the math light portion of this is if I was to give you, let's go with, you had 3,700, okay, units. We'll go and call them units for right now, whether they could be molecules or not, but units of, let's go with potassium nitrate, okay? Now, are you expected to know what the formula for potassium nitrate is? Yes, you are, but just not right now. It'll be a good few, weeks, if not months, before you need to know that that is potassium nitrate. Okay, I'll tell you that it's potassium nitrate, and I'll give you the formula right now. Okay, if anything, this unit's going to introduce a little bit of introduction into what these names mean. Okay, so if I had 3,700 units of potassium nitrate, okay, I want to know how many oxygen atoms are there. Okay, and so in doing so, I would simply take what I'm given and put over 1. We're going to do a little bit of dimensional analysis right here. Okay, but they're all going to be pretty straightforward. They're all one-step processes. Okay, so if I have 3,700 KNO3, right, over 1, and then I'm looking at the formula itself going, well, in that formula I have 1 potassium, I have 1 nitrogen, and I have 3 oxygen. And I want to know how many oxygen atoms are there. Well, for every 1 potassium nitrate compound or unit, I have 3 atoms of oxygen. Okay? So, I'll do my math, and I cancel my units out. Potassium nitrate cancels out. I'm left with atoms of O. Okay? I end up with 1110, so 11,100 atoms of oxygen. Okay? Now, hopefully that, causes a red flag, and you're going, well, there's 3 sig figs there, there's 2 sig figs there, so what you would have to do is, of course, apply your sig fig rules, which would be 11,000, and atoms only has 1 T. Okay? So, some of them are pretty straightforward, like so. Others might be a little more complex, so let's go ahead and take a look at one of those. Okay, how about we have 20, or let's go 2.4 times 10 to the 8 units of, how about ammonium nitride. Okay, this would probably be a fairly complex one. Okay, so I want to know how many nitrogen atoms are there. How many nitrogen atoms do I have? All right. So, first thing I need to do is I need to look at the proportion or the ratio of different elements in this compound. First thing I need to do is identify that there's only two elements. There's only nitrogen and hydrogen, right? So how many nitrogens do I have? Well, what this means, this little subscript right here, that means that I have 3 of whatever's inside those parentheses. So that means I have NH4, NH4, and NH4, right? And then, of course, I have my 1 nitrogen on the outside of the parentheses. So looking here, I have 1, 2, 3, 4 nitrogen, and I have 4, 8, 12 hydrogen. Okay. Now that is my my 4 nitrogen to 12 ratio. Of course, I could change that, okay, if I wanted to reduce to 1 to 3. Okay, but even though you might think that that's the direction to go, the formula for that is not in a 1 to 3 proportion, so to speak. It is in a 4 to 3, but I want to actually have a number of atoms there. So I need to use the 4 and 12. All right? So doing that, I'll go ahead and go 2.4 times 10 to the 8, okay, units of ammonium nitride. Delete all this stuff here. Okay. And I want to know the number of nitrogen atoms. Well, put that over 1. And I know that for every, in this case, I want to know nitrogen atoms. There's 4 nitrogen atoms. So there's 1 unit of NH4N has 4 atoms of nitrogen. This is why it's important that I don't reduce, because this number needs to be 4, because that is telling me how many nitrogens, 1, 2, 3, 4, I have in that formula. Okay? Now, as far as writing the formulas and naming them, we'll get to all that. I will give you the name, I'll give you the formula, I'll give you everything you need. You just need to be able to convert it with dimensional analysis to determine the number of atoms of a particular element in a compound. Here, that times 4, here we go, 9, 6, let's put that in scientific notation, is 9.6 times 10 to the 8 atoms of nitrogen. Okay? So, that's a brief breakdown of a simple and complex problem, and then if you guys have any questions about any of them or any of them in between, be sure to ask in class.